This is the first section in the chapter on conditionals and loops, and in this video we'll be looking at Boolean expressions. Okay, this is on flow of control. As we've seen so far, unless we specify otherwise, our statements, or the programming statements that we write, are executed one after the other in a linear fashion. And this is not always a good thing. Sometimes we want to make decisions about which statement we want to execute as opposed to another one. And some of the programming statements that we have available allow us to make these decisions and to perform repetitions. I mean, we might make a decision to do one path or the other path, or in some certain situations, we want to repeat a number of steps until some condition is met. Now, all of these decisions are based on what are called Boolean expressions, and in most programming languages, they are also called conditions, and they always evaluate to true or false. So, very good thing to remember, only true and false for Boolean expressions, much the same as the Boolean variable type can only have two values, true or false. And when we actually get to one of these decision or Boolean expressions or conditions, the order of the statement of execution is called flow of control. So we can dictate the flow of control based on Boolean expressions. Now, conditional statements let us choose which statements can be executed next or will be executed next. In a lot of programming languages and in some of the textbooks and websites you might visit, they might be called selection statements, one and the same. These give us the power to make very basic decisions. We either go one way or the other way, so it's a true-false sort of situation. We can get a little bit more creative with them, as we'll see a little bit later. However, in the first instance, they are just really basic. So in Java, we have conditional statements in the form of if, and then an if-else statement, and we'll have a look at those, and also what's called a switch statement, which will be explored a little bit more in chapter 6 when we get to that. In this particular instance, we'll be looking at the if and the if-else statements and how we can deal with those. So, Boolean expressions. There are a number of these that we can leverage, and they often use one of Java's equality operators or relational operators, which all return Boolean results. Remember that the equals sign is an assignment statement, so in order to get something equal to something else, we need two equals lines, so we can use that. We can use not equal to, which is an exclamation mark and an equal sign. Then we have the mathematical or relational operators less than, greater than, less than or equal to, or greater than or equal to. Again, I'll highlight the difference between the equality operator, two equals, and the assignment operator equals. So, an if statement allows us to leverage a Boolean expression to make a decision on whether a piece of code is executed or not. So here we have an if statement where we rewrite the word if, and then in round brackets, we put our Boolean expression. And in this case, it's if sum is greater than max, where sum is calculated from somewhere else and max is a constant used in our program, then we assign the value of sum minus max to delta. If sum is not greater than max, well, delta will never be assigned a value. So first of all, we check the condition. And as I said, if the value of sum is either greater than to the value of max, or it is not. Two choices, true or false. If it's true, the assignment statement is executed. If it isn't, it's skipped. So let's have a look at a little program called age. No, we won't. Maybe we'll look at it later. Okay, logical operators. Boolean expressions can also use the following logical operators. So we can join expressions together, and we can have not, the logical not. We can have logical and, which is two ampersands, or we can have logical or, which is two pipe symbols, or two vertical lines, which are usually found above the backslash on your keyboard. They all take Boolean operands and produce Boolean results. Okay, so we have two expressions, and we can either and or them against each other, whereas the logical not is only a unary operator and only operates on one operand, so we can only not one particular expression. So logical and logical or are binary operators, and they operate on two operands. So we are comparing two things with and or, and we are reversing or inverting a single thing with the not operator. So let's have a look at logical not. It can also be called logical negation or logical complement, but most of the time it will be called logical not. So, for an example, we have a Boolean condition A, and it's true. Then if we put not A, i.e. exclamation mark A, it becomes false. If A is false, then not A is true. And using the truth table, we can see the particular values, where A is true, not A is false, not A is true. Can you get that? Logical and logical or are written with A and B for logical and. Is true if both A and B are true and false otherwise. The logical or expression, A, vertical line, or pipe B, is true if A or B or both are true, but A or B or both are true, and false otherwise. So let's have a look at logical and logical or in the truth table, showing all the possible true-false combinations of the terms. Since and or both have two operands, there are four possible combinations of conditions between A and B. So if we start off our truth table by listing A and B, true, true, false, false, true, false, we get all possible combinations. Then if we look at A and B, it is true and false otherwise. If either one of A or B is false, then A and B is false. The only time it's true is if they're both true. A or B are always true unless they're both false. So, if we're using logical operators, well, then these expressions can form very complex conditions, as is indicated here. We could say, if total is less than max plus 5 and not found, well, then we're going to print out processing. So in order for this to actually print something out, total must be less than max plus 5 and not found must be true. Then we will print it out. If either one of those expressions on either the left or right hand side of the and is false, then we will never get the printing. So the logical operators have a lower precedence than the relation operators. In other words, the expressions will always be evaluated before the logical operator is enforced. Now, the not operator also has a higher precedence than and or. So in our expression above here, total less than max plus 5 would be evaluated, then not found would be evaluated, and then both of those would be evaluated against the and operator, the and logical operator. So, any particular specific expression can be evaluated using a truth table, and this is always a good method to work out whether your logic is correct. We can have a look at total less than max, and we also always, if there's the different values that we've got false, false, true, true, and then we have false, true for found, and therefore not found is true, false, and total less than max and not found. If they're both false, it's false. If they're both false and false, they're false. True and true, true. True and false, false. So the only time that the expression would be evaluate to true and actually fork the processing of the program through that mark would be if total less than max was true and found was false, therefore not found becomes true. So if in doubt and you're worried about how things are going to be evaluated, it's always a good idea to draw up a truth table to actually check your logic. Now, because we've seen in the truth tables that because both expressions have to be true for and to be true, and both have to be false for or to be false, we can actually come up with this idea of short-circuiting the processing. So what it does is it checks the left-hand operand or the left-hand expression, and if it's sufficient to determine the result, well then the right-hand side is never evaluated. So in our expression here, we have count not equal to naught and total divided by count greater than max, system out println testing. Because it's an and, if count not equal to naught is false, i.e. count is greater than naught or less than naught, well then the right-hand side will never be evaluated, because as soon as one of the operands is false in an and, the whole thing is false. If that was an or and count was not equal to 0, we could determine if that was true, i.e. if it was greater than or less than 0, or then it would be false. If it was equal 0, then we could also make a determination. So if it wasn't equal to 0 and that was true and it was an or, then we wouldn't check the right-hand side and we would print out testing. When you're doing this sort of stuff, make sure you use it very carefully and also work out through a truth table what is going on before you do it. Okay.